Okay, this video is about limits and continuity, and then we're going to talk about differentiability at the end. So, limits describe the behavior of functions and allow us to describe rates of change. So we read this, I look at this one here. This means the limit as x approaches 1. So what do? We just substitute 1 into that spot. So we say equals 1 plus 3, and then we put 1 squared plus 3 times 1 plus 1. That gives me 4. 1 plus 3 plus 1, so that's 4, 5. So my limit as x approaches 1 equals 20. What about if the denominator contains an x? So I look at this one here. It says the limit as x approaches 2, and I've got x squared plus 5x take 14, and I've got x minus 2. So straight away we know we can't divide by 0, so x cannot equal 2. So what I'm going to do here, top line, I'm going to factorize factors of 14 that add up to 5, 7, and 2, and it's going to be x plus 7, x take 5. What do you notice? My x take 2 cancel out, so I'm left with x plus 7. I want the limit when x approaches 2, which is 2 plus 7, which gives me 9. So remember, x is not allowed to equal 2. Okay. I now want to talk about continuous functions. And a function is continuous. If it can be drawn without lifting your pencil from the page. Now, a more formal definition is this one. If the function of x is continuous at x equals a, then the limit as x approaches a of function of x gives me the y value at a. So essentially what that's telling us, the limit must approach the same value from the right as it does from the left. We're approaching, and it should be the value that we're looking for. So we say this is approaching from the negative side. So from the left has to equal approaching from the right hand side, or the positive, yeah? So they should give us the same values. So let's have a look at this one here. Here's my little graph, and you'll notice as I'm coming from the left this way, I'm approaching x, y equals 1. So the limit as I approach from the negative is from negative, I'm approaching from negative infinity. So less than 0, x is less than 0. So as I'm approaching 0, so the limit as x approaches to 0 from the negative is going to be minus 2x plus 1. So that's going to be 0 plus 1 equals 1. Then I look at the limit as I approach from 0 from the positive side. So I'm approaching from this side. On that side, the equation is 2x. And you'll notice that I'm approaching to 0. So the limit as I approach 0 from the negative side is not equal to the limit as I approach 0 from the positive side. And so what's that telling me? This is not continuous. At x equals 0. And that leads me on to talking about differentiability. For a function to be differentiable at x equals a, the function must be continuous at a, and a tangent must be able to be drawn at a. So look at my little graph here. I've just drawn this by hand. Got a straight line coming and it's approaching, and you'll notice there's a discontinuity here. I have to lift my pencil at x equals 0. So x equals 0 here. I have to lift my pencil. Then it starts back up. I get to a sharp point here at x equals 4. And I get to a hole at x equals 5, or an end point. It doesn't really matter whether it's a hole or an end point. Because it's an end point, it's not differentiable anyway. So what do we say about this? This graph is not continuous at x equals 0 because I have to lift my pencil. The limits are not the same. If I limit approaching from the negative will get me to 4. Limit approaching from the positive gets me to 2. And then I look at x equals 5. The limit as I approach from this side, well, there is no limit as I approach from the other side, and it's a hole anyway. So it's not continuous. So therefore, the derivative does not exist at those points. Then I look at what is happening here at 4. It is continuous because I can draw that without lifting my pen, but I can't draw a tangent. If I draw a tangent from this side, that tangent is going to be going in one direction. If I draw a tangent from the other side, I'm not going to get the same tangent. So the derivative does not exist at that point. So a quick little summary. Function of x is not differentiable when we have holes, sharp corners, which we call cusps, or endpoints of a domain. So at an endpoint, it's not differentiable. Okay, thanks.